Hello, welcome to a new edition of IoT Happy Hour. I'm here with my suspect colleague, David from Belena, but we have a guest.
We sure do.
Hello, Nico, how are you?
Hi, I'm great, and how are you?
Doing good. I see a couple comments rolled in here. Where are we? We're watching the cricket. We're always about 2 minutes late. Mark, we'll get better. We'll improve on that. We promise.
Exactly. We were not on time at any.
Yeah.
But yeah.
Episode number 56, and I know I'm very excited today. Mark, are you excited?
Absolutely. It was one of my desired episodes to know more about Belena in space.
Yeah, we're going to be talking. We're going to be talking Belena in space. So I have a strange feeling we're going to be talking about some rockets, some rovers. What on earth? HAL 9000. So this is going to be a good one. Us. I'm David, developer advocate. Mark, you want to say hello, and then we'll let our guest.
Mark, as well, developer advocate based in Barcelona.
And
Nico, maybe make a quick introduction about who you are and what you do.
A quick intro.
Well, I'm working for the German Aerospace Center, the DLR, especially for the MUSC. And well, I think we are going to talk a little about a little project of ours, which we're launching into space, which was using Belena.
Awesome.
And looking forward to know more about next missions.
Yes,
that's gonna get here in some minutes. Should we run quickly to the next section to get into the topic? What do you think?
Sure thing.
Well, wait a minute. We can't just skip over what's on your desk like that. What do you mean?
No. I mean, let's get into what's on your desk. But before that, maybe we can mention that Belena is hiring. Did you know that, David?
You know what? I did know that. Let's see. You've got it on screen here. Technical sales lead, and that goes for both EMEA and Americas. Now, we've mentioned in the past that we are primarily a remote-first organization. No, I shouldn't say primarily. I should say we are a remote-first organization, but we do have some offices. We've got Seattle, we've got London, we've got Athens, we've got Milan, we've got Galati. So we do have some clusters of employees in certain geographic regions. And then you can see here, so EMEA versus Americas is typically for time zone coverage. So as leads, customers, or potential users are coming in, we want to make sure we have coverage on their time zones. So that's the split there for EMEA or Americas.
And same happens for site reliability.
Yeah, same for SREs. Security engineer, front-end engineer, and design your own role we've talked about in the past. So I'm not going to go into detail on those because I want to save time for Nico down there. But by all means, give those a look. I'll drop the link into chat real quick. If Mark, you want to start us off on what's on your desk.
Well, so maybe we didn't mention that Nico is a Belena ambassador. So maybe it's first time in 56 episodes that our guest will sing "What's on Your Desk" song. Well, I don't know if he knows what we are talking about.
Nico,
I know this format, so I'm completely willing to go ahead with this. I got something prepared for you, so we could start with this.
Wait. We have to sing.
No, well, let's play the jingle.
What's on your desk?
Now, Nico, if you are feeling up to it, we can certainly have you sing and record a rendition of that. It's pretty simple, as you can see, but we can save that for another day.
I guess I'll leave that to the professionals.
That's Chris. Chris is the professional.
Perfectly.
All right. And I see we've got some comments rolling in already as well. And one of them is from Heidelberg. Nice to see you, Frau.
So it's our guest who goes first, or we go first, David? This is very rude that we go first.
I don't know. I'm a little concerned that he's going to have some really amazing things on his desk. So I'm thinking we better go first. Yeah,
Okay.
Mark, you want to go?
Yeah, look. So today I received some packages from AliExpress, David. It's like Christmas, you know.
I don't like ordering from there because it takes 4 months to arrive.
So I got another type of, just to test the Lorawan coverage. I got a new antenna. I don't know if you remember the previous one, but it was
I remember it quite well.
I don't have it here. But I just ordered a 3 dBi LoRaWAN antenna, and it looks like this, and I'm going to test it this weekend. Right. How different it's from the other one was 5.8 dBAs. So I'm going to test how different is the coverage provided by 3 dBIs instead of 5. So maybe one day we can talk about what's the difference.
I was just going to say, so then 5.8 dBi on the previous one, 3 on this one. Are you expecting then that you get roughly half of the range? Is that is it a 1-to-1 relationship there, or well, I guess 2-to-1?
I'm not an expert on antennas, but I think it's the angle. Maybe Nico knows more about it, but I think it's the angle of exposition of the signal and the.
Well, after you've got some experimentation complete, that might be a good one to explore. Range coverage and proximity for the LoRa stuff. Awesome.
You will know what to install on your roof.
Yeah. Well, I need something to install on my roof, but we'll it's getting a little warm to climb up there. I don't know. We might have to wait till the fall.
If it survives in Phoenix on your roof, so at all.
Well, we've tested Nico. I don't know if you've seen last year's episodes, but we'll do some hot weather testing. I know, like Nebra's got that outdoor one. We'll see if that thing really survives. But all right. Anything else? What else?
I should. No, it's okay. I can keep the other things for next episodes. But I should. JR is mentioning that. We shouldn't call this an antenna.
That's not an antenna. No way. All right.
I will try to. And this antenna actually it's for helium hotspot to try the coverage. So I don't know. Let's see.
Yeah, we'll devote some content to that in the future once you've got some testing complete there, because that'd be very interesting. Whether it's directional, bidirectional, whether it, what the range looks like, signal strength, what you can pick up. So that's all neat stuff.
All right, all yours.
It's all mine, huh? All right. So in the mailbag this week arrived from the UK was.
AliExpress.
No,
AliExpress UK.
AliExpress. No. Was this? Let me take the cover off of it. This is for, as you probably know, I am lucky enough to be an ARM innovator, and they sent over this kit.
Oh, that's Lego Widow 2.0.
Yeah, for some sessions that we're going to be doing next week, and so I thought this actually worked out to be quite timely. I can build a rover and put it on one of Nico's rockets, and we can send this right to Nico. Where are you going next? The moon? Mars?
We hope for the moon. Actually,
you hoping for the moon? You think this thing could survive on the moon?
Well, we can tweak it a little. I think we can. we make do with what we get. So
all right. So I'm ready to join the team. I'm going to be a rover expert pretty soon here.
Absolutely.
We always need more operators. And so
it's pretty big. All right. So that's what was on mine. Nico, let's see what we've got on your desk.
Sure thing. I thought you had to. Can you give me my share?
Yes.
Because
that I had this on the screen.
Yes, perfectly. I just went with the camera approach. I thought, because of all the nice comments we normally got, we will start now with David. And this is the soldering station. We turn it on like this,
No,
and then you grab the handle.
no,
and
you don't need that. You don't need that. You some electrical tape.
Okay, we have this running joke with getting David to solder.
No,
I prepared already something. So we step those. We just ignore those steps and go forward like this.
There you go.
I just
what is that?
Working with a little environmental sensors, which we actually wanted to build for our own racks here. So just like monitoring if everything's working right on the earthly IT, as we can say. So we got some temperature sensor, some humidity sensor, some light sensor, a microphone. We got a CO2 sensor, which actually a good friend of the flight medicine or aerospace medicine donated to me, and I had not even wired it up. I'm so sorry for this. I will do this justice at some point. And we can see it's really like nice in here. We got about 29 degrees Celsius in here. I'm really feeling great. And so it's kind of like a neat idea to just like create something which can monitor our equipment and see if something's going to fail at some point, or fire's breaking out, or some high amount of noises because some rate controller's beeping or something like this. And we started this thing and wanted to go ahead, and it was doing really, really well until I realized I did not want it to only do this with Wi-Fi, but also with Ethernet, and wanted to do it in a secure way, so with SSL. And turns out doing SSL with Ethernet and an ESP32 is not really an easy task, so I'm a little bit stuck at the moment. But anyway, there are some vacations coming, so maybe we will do something with this. So that's currently my thing on the desk. And the other stuff which I can give the honorable mention is obviously this little guy, the Compute Module 4, because it's just like awesome. I'm having so much fun with this. And the other thing, which is still in this box, but I have this already lying around here for 2 years, is the Teensy, because Paul Stoffregen is doing such an awesome job with getting completely off the charts, overpowered Arduino-like controllers in here with 600 megahertz. So we can do quite a lot with this stuff. And he's an awesome guy and contributing so much to Arduino and everything. So I wanted to give a shout out here because let's do. So that's what's on my desk at the moment.
All right, Mark, do you want to cover this this conversation in chat now?
Yeah, I mean,
Nico, there's an ongoing debate. Now, there's obviously there's only one correct answer, and we already know it. But I noticed that you left the film on that little LCD. It still had the tab and the protective screen. And I just want to inform you that that's awesome, because that is the correct way. Now, Mark, he believes that you're supposed to actually remove that. Chris also thinks that you're supposed to remove those. But the truth is, no, you're not.
Maybe you saw the little hot plate I just got from the mail, and I can inform you the tab's still on there. So it's just like how I roll. I'm sorry.
It makes them work better. It's a fact.
Like RGB's working PCs better. You know.
Exactly. All right. Well, that was awesome. I like
when you're in space, you definitely need all the protection you can get.
Yeah.
It's getting cold up there.
That's right.
Yeah, just in case you get a scratch on your display. Yes, of course.
All right. Well, let's get into it. Nico, sure. I'm ready to learn about rockets, rovers, and sending Belena into space.
Yeah, sure thing. Let's go ahead.
Let's do it.
I think, as a matter of fact, as I'm a little grain of sand in the overall process of getting stuff into space, I wanted to reach out a little bit and not only present the Project Apex as we had, so my little experiment, but also give a shout out to all the people which make that even possible, because space is a team effort. We can just say it like that. And so I'm going to talk a little bit about us, about Musk, and our partners, which make the whole operation work. And then we get into the nitty-gritty, going to the old Apex mission, the current Apex mission, which is slated for launch, and the future of the program, and learn a little thing or another thing along the way. So yeah, let's get started. So first things first, I'm working for the DLR, for the German Aerospace Center, for the MUSC, or Microgravity User Support Center. What we are doing basically is we are helping scientists with doing experiments in space in any kind of microgravity environment. So where you float is where we be. And we're doing this in a whole cycle. So we're doing preparation for experiments and planning, helping them with development, doing operations for experiments on Mars, on small bodies, on the ISS, on laboratories, and also the data handling, extraction, getting this data to the scientists so that they can have the results and work with it. And I think our biggest topics where we're really working on are material sciences, life sciences, radiation is also a thing, and small bodies. And small bodies does not mean we have something like a CubeSat or something like this. And obviously, it's more like asteroids, comets, because we also have landers on those. So that's kind of like the part where Musk basically shines and has a lot of heritage. And regarding microgravity and how to get microgravity, we got different kind of platforms which we are using or which are used in a way. So we got drop towers for like simulating microgravity on Earth for about 9 seconds. We got these nice planes doing parabolic flights where we get about 20 seconds about there. Then obviously the thing we're going to talk about are sounding rockets or high altitude research rockets, which can get us about, or in our configuration, about 6 minutes. And then we go for the more permanent installations like satellites, International Space Station, so for example, especially the Columbus module on the International Space Station, and also in some way or another landers, as they are also in kind of an, let's say, not really 1G environment if they are on a small body or comet or asteroid. So to do this, we have 2 control rooms. So we got the big control room for the USOC, so for the ISS segment, where we are currently doing 2 laboratories for material physics and science. So this is EDR, EML, and MSR. We got these consoles actually in the picture right here. In the front is EDR and here. And we also got the MSL segment. These are those 2 rows. We got doses. This is a radiation measurement experiment, which is here. And we got the biolab for the life sciences. And there's a little row directly here. This is for the ground controllers, which try to keep everything afloat and running, like the 6 live videos or the astronaut schedulers, we could say, where we see what they are doing when they are doing. This is for basically for the ISS part. And above, it looks like this somewhere. There's maybe Alexander Gerst floating in front of the EDR/EML lab while we are trying to perform science up there. But in this special case, it's normally done at night, so we will not be in front of this while we're doing our stuff. And then there's obviously the small control room for all kinds of landers, satellites, and everything. So we're not operating rockets or the stations from our side, only the experiments or laboratories. This is an important part. And as such, we currently are working on the HP Cube, so the Mars Mole on the Mars Insight mission from NASA and JPL. We're also working on the radiation experiment RAMES from the Eucropis satellite. Soon to be, also from this control room, the next Apex iteration we're currently preparing for landing. But I guess Musk is most well known for the Philae and Mascot landers, which landed on an asteroid and a comet. Yeah. So these had some backlash. So, and there we see Mars Insight with the HP Cube mole. So, and now that we know a little bit about what Musk is, we have to see it in the whole context about how the German Aerospace Center works. We got a lot of different institutes. So the thing where we are actually is called RB, or Raumfahrtbetrieb. This is space operations and astronaut training. So we're doing all kinds of space. And the most memorable things here are the German Space Operations Center, which are basically performing operations on satellites or other manned missions. We included in this, we got the Columbus Control Center called CC, which is basically the main control center for the Columbus module on board of the ISS, so close cooperation between us and them. Then obviously we are there. And then there is also staff from Moraba, and these are basically our rocketeers. They are preparing rockets for missions, so this is really nice, our next door neighbors, even if it's not physically, but in a structural way. And yeah, they're basically preparing rockets for example, the MARFOS program. So the Institute of Material Physics in Space is doing a great job in running the MARFOS program. This is basically material physics experiments under space conditions or under microgravity conditions. And they are basically collecting experiments from all kinds of fields, also for life sciences, putting them into a rocket by helping with Muraba and communicating with them, and then launching them into space. So they're basically like the management of the overall thing, and they're really important. So we're also really happy to have them there. And if we're talking about which kinds of experiments, well, MP himself, they are going to have obviously some material sciences experiments which they are putting into the rockets, but also they are so gentle to let other, let's say, operations fly with them, like us with a technical demonstrator, but also the life sciences. And this is a good point, like the Institute of Aerospace Medicine, which we are closely cooperating with. We have got there the gravitational biology, which is basically the thing we were working on Apex, on the future Apex missions. And we got the radiation biology, which is always a little bit involved because it's always cool to have all these people in the background and basically seeing them to do so much stuff. So also the Rames experiment, which I was talking about, is coming from actually this working group. So there are we're having a lot of small groups which having a huge impact and doing different kinds of stuff in different kind of projects, like putting a radiation instrument into a rocket or onto a satellite or onto the ISS. So there's a lot of stuff that can be learned from there, and that's cool, just like because you're all working in your fields where you're good at, and then as soon as you join forces and work with each other, you get a really good stuff out of there. So I love this interconnected work very, very much. So, and yeah, obviously we're talking about rockets. We cannot go by this. So Muraba has a really little nice cute collection of different kind of carrier systems which they're working on and actually developing themselves. So they're taking rockets especially from Brazil. We got there something, so Mark, and also old military surplus and converting them into research rockets, basically, and letting them launch. And for the rest of this presentation, we're going to be with this BSB 30 configuration. This is the one we were basically launching. And the new one, which is now new, is not yet on this chart because it's so new that it is not there, but it's very interesting. And it will basically look like this if we're launching from Kiruna, which is in Sweden. But Muraba got also other launch pads in Woomera in Australia, in Japan, in Andonia in Norway. So kind of like you can see what you need, and then you get a perfect launch pad.
Okay, now I've got to stop you because I've already got a ton of questions, but the two most important ones are, did you say that you're purchasing rockets secondhand? Now, is this black market? Can I go out and buy a rocket? Can I?
You cannot buy a rocket, no.
Okay.
It's actually like this. There are you're doing this in kind of like a corporation. So obviously, as we're talking with military surplus or old things, this is a sensitive topic. So it's obviously only done because we are in part also a governmental institution. So it's a lot easier for us to integrate into this and also to make all the necessary, let's say, waivers and everything. So we also have to keep track of this. So it's a really sensitive thing. And, no, it's basically it's not possible to get your hands on something like this and there's a lot of things. It's also the reason why some stuff is not allowed to be shown live and stuff like this. So it's but I think of it as a good perspective, especially when it comes to surplus. If you're using military stuff for good use other than using it as a weapon, it's kind of like I think that's kind of like a cool thing, just like trying to do something for health research or something which obviously could be used for some other purpose.
Yeah, repurposing for science, absolutely. I mean, obviously,
it was Elon Musk who went to Russia, right, to try to buy a couple of
yes, he did in the beginning. But, luckily, he didn't get anything really. So you see, what he built now is way more interesting.
The second question, and this one is a serious one. Obviously, I was joking on my first. The second one, though, is a serious one, which is this: you just mentioned you're launching literally from various places around the world. I didn't hear you say that you were launching from Germany. So all of these appear to be remote launch sites. But your mission control, obviously, your center of operations there that you showed was in Germany. So is that, I imagine that makes for some challenges.
Definitely. I mean, packing up all that stuff, getting it up there is always a challenge. And I mean, most of these missions are currently still centered around the idea that you're doing this on site. I mean, these are really, really local launches. So you're having, I mean, the rocket is not traveling that far. You can recover it after it plummeted back to Earth via helicopter. So you're obviously not going to go a really big way in kind of like an x-axis on the map. So that's not a problem. A problem is obviously security, because of you do not want to have anything to fail or anything to basically crash into someone's home or endangering people. And these are specified areas which are basically locked zones where this thing is stuffed. And there's a lot of mathematics which going into there. And there's the testing of the rockets also as well, how they're flying. This is actually something. And there are actually missions where I was involved with where something was kind of like canceled because there is a chance of something, a little bit of percent that it could go over this. There is nowhere there, but we do not allow for this. So there's, it's really good to know that you're working with people which are taking this really seriously. That's not in all parts of the world, but here it is basically. And we are hoping for having something like an own launch platform or anything in more heart of the Europe or in Germany or somewhere in the seas or something like this from an old oil rig or stuff like that. But that's something the politics are still talking about. So I think we are really happy, especially with the support from Sweden, where we're doing a lot of operations. This is really working out great. So yeah. But the whole operations is taking place basically on the block. You can see basically in this little house there's a bunker, and there basically is the operations. We got an antenna. They're sitting on the other side of the map, and then they're basically doing everything local. But we're going to change that, or I'm going to change that with the next mission.
Neat.
So you are not in Kiruna when this is launched?
This is I was once in Kiruna because I was only for one mission there, but for the next mission it could be that I'm here and still being able to supervise, but we have to move on to get to the point.
Oh.
Okay.
I don't know if we have a colleague from your team or something, but
yeah, it's a good colleague for me. Yeah. That's a cool thing. Definitely.
Awesome. Welcome, Akil.
Okay, let's just get into how we built the first experiments and how we got it running. So obviously the first idea was we wanted to do a small mission to just see, can we get this into a rocket, let it communicate with the service module, a technical demonstrator, and it should be based upon the normal commercial off-the-shelf components. So basically stuff like Raspberry Pis and everything you can buy for cost reasons. And there you go, developing software, hardware, you will first get your requirements. Yeah, what do we want actually to do? Okay, we want to have some temperature pressure sensors. Camera would be nice. COTS components because of cost. Atmega we do not like. Not because we do not like Atmega, we love Atmega, but Atmega has been done so many times on CubeSats and everything. We want to do something new, so let's do something different. And there was standing with an ESP32. So resilient design, obviously, we cannot have this thing fail under no circumstance. And because it's the first time we're doing this, we have to go in.
We are losing your voice, Nico. Is this me or?
No,
test. Better?
There, you're back. You're back.
Yeah, okay.
Better.
So we have to do this in a little bit more. We have to be able to incorporate last-minute changes, like something fails, because we're doing this for the first time and getting our feet wet. So we also have to pay specifics, a little bit of say, we have to look out for specific special aspects, like there are going to be a lot of force on the whole hardware doing launch and doing landing. We have vacuum, so we do not get heat away from the components efficiently. We have huge temperature spikes, so transporting the rocket in minus 40 degrees, then putting it into the tower, launching it, letting it cool out somewhere, and power dissipation, something like your Raspberry Pi just burning up through and just keeping a little nice heat bubble around it and dying by itself. So that's something you have to keep in mind. And if you're done with all of this and still not confused enough, you get the service manual They're really like manuals for this stuff you can get, and trying to read into there and see what they say, what you still have to do, like RF maybe, or like power requirements or everything like that. And you can make so much temperature and noise. And so you're getting through all of this, and then you start to do choices, because otherwise you won't get anywhere. So the basic idea for this production was we wanted to do a normal Euro card, like soldering it ourselves. We're using sensors from mobile phones and everything, so we need breakout boards to quickly be able to change them if they break during some testing, something like this. Silicon cables and leaded solder is obviously important for huge temperature spikes, because non-leaded solder will break at some point. And for space use, leaded solder is still allowed, so we can buy, no problem. Nuts and cables are going.
There is no solder tape, David.
You just tape it right on there. So
no taping involved. We like to use, and this is the next point, we like to use epoxy. So I like using epoxy.
Now hold on, epoxy? I could work that. Okay.
And instead of duct tape, we're taking the more expensive duct tape, so Captain Tape, but it's basically the same, but it's looking a little bit more cooler. So, but other than that, it's completely fine. And so you have to basically get everything right, like especially in the Pi Zero, look that your SD card is not going to fly out, and making some tabs on your holders and everything. And there's a lot of stuff you're thinking about, and I'm so happy that most of the stuff I was thinking ahead, kind of like, I'm a little bit proud of that, and not just like figuring it out the hard way. There were some occurrences where you had to find out the hard way. It was not pleasant, but it did work on the end. So
Nico, maybe I'm asking something stupid, but do you need any C certification or something like that?
We are doing some kind of like interference tests. We're coming to this later, but we do not need really kind of like some CE certification, because it's all experimental stuff.
It's not a product, right?
Yeah,
right.
And but we obviously cannot include radios or something like this. Or if we have them, we have to make them switch them deaf, so otherwise we will have a lot of problems with this. So then you come up together with some kind of design, and this was kind of like the main design. The obvious failure is we had no telemetry at this time, and I think the most important, interesting stuff was the Raspberry Pi Zero, which we had loaded with balenaOS for obvious reasons. And the most obvious reason is we wanted to have zero downtime at all costs. So running the whole camera application in the container, and being sure that whenever it would crash, if it were to crash, it would be completely just restart and will be there again. And also for the fact that the balenaOS was partitioned in such a great way, so that you can power it off at any moment and it will still recover, the container will come up. It was the perfect tool at this time to make that quickly available, where you had to do a lot of other stuff. So that was really a great thing which kept my life a lot easier. So this was the main interesting point. And then you start like you normally do. You start a little bit of breadboarding with some components, not precisely the elements you will put in later, but just like to get a rough idea. And then we had the good phase that we found a new home. Obviously, in the start, we were just like thinking about having it as a technical demonstrator. Then our friends from the Aerospace Institute, from the medicine, came over and asked us, hey, we would need a camera for our microscope. You got a camera and have nothing to do with it. We got space in our experiments. You need space. And it was a match in heaven, you can say. And so we're just like, hey, let's put ourselves together. And so we ended up on top of the Selfix2 experiment from Jens Hauslage, from the gravitational biology. And we're just like, okay, let's measure and see if it would fit, because at the point it was still breadboarded or not built. So we're just like, okay, now we can figure out something. And from this moment on, it's all started. We were just like, okay, now we're using this Euro card. This will work out. And then we started just like try placing the components, seeing which matches. And obviously in the next picture, we can see that those nasty DC converters will be moved away from this temperature sensor. Like these are here, this one is here, so that we do not get any false readings.
But these are like Adafruit and...
These are Adafruit and SparkFun things. So these ones are from SparkFun, these both. And the rest is Adafruit, obviously, because it's high quality components, it's still cheap. and it's doing a great job. So why should I do something else and getting something more expensive?
Well, you save a lot of time also. You don't have to
Yes.
go out and build that board
And I actually have to
yourself.
admit,
You gain the capability just right off the shelf.
yes, and what's really interesting is we got these socketed, so these are basically all, really socket. You could basically, and this was a great idea from Jens Hauslagov, you could just like basically pull them out again, and just like put another, and if it's something were to break, and then shortly before launch, you just like resin them down, so they will be secured and everything's fine. But this was kind of like a historic moment. The first time I powered this thing on, and it's just like there's a lot of cables under this. It was like, okay, everything is green, everything's working, no smoke. This is always you can do as much testing, but the real thing is still the real thing. So yeah. And then because we're doing a lot of new novel approaches, just like behind me is actually this printer sitting there, printing the whole frame, which was holding the experiment on top of this metal construction, printing this from PLA, FDM, worked a treat. Was really good. Yeah. Then, as soon as this was all built, we went to the vacuum chamber to test this out, if it will work for long duration, having it for an hour or something like in there, see if some heat problems come up or something like this. Did work out great. And then there was the great moment where we kind of like put everything together, also made the interface test so that both experiments in the same container will work. And these are basically these experiment containers. And as you can see, there are a lot of screw holes in there because this is basically the outer skin of the rocket. We're just like stacking those on top, threading them through, and this is how the complete payload forms. And
it's crazy how much of the rocket is devoted to the engine versus the payload. I get it, I understand, but you got this giant rocket and your payload size is just this tiny little piece.
They can range. So you can also stack or get them in other sizes. But as you can see, we are basically we are really small in this whole thing, and we get then stacks there. So all these experiments are built by different groups, and that's kind of like the interesting. And the first time they see each other is this called bench test, where you have all these little containers lined up, put together, and put into the service module, which is kind of like giving them power, giving them data, maybe even video. And this is kind of like a really interesting moment because you will have your interference test with the putting on everything at the same time and see if something breaks, if something's behaving oddly and stuff like that. And if this is going great, then you're going for the next step, which is making you really pale, the environmental testing, which means you have everything stacked up.
Nico, maybe first to get into...
Sure.
So are there any real-time requirements for these devices? Girish is asking the chat.
That's depending on the kind of experiment you're having. So there are some kinds of experiments where you're just like running basically completely normal microcontrollers or Linux machines, or even some x86 computers in an industrial form factor put into there. So I think a lot of these times, these systems are running without kind of like a real-time operating system on there. But we also have high-speed cameras and needs where you precisely need some timing. So at some point or the other, it's dictated by your experiment. So we were just like an environmental sensor, so this was kind of like completely okay with this.
Okay, and on electricity point of view, so you have a socket on that container into the rocket, or how do you get electricity?
Yeah, we're using DSUP pins, so like 15-pole connectors, and we're just like making this and just like connecting this with like nice cables. I mean, lying around here, but it's just like basically a smaller printer port for the oldest of us that still remember this.
Okay.
Okay,
that's interesting.
Yeah. So you bring power in from literally from the rocket, from the chassis or whatever. I mean, it must have some battery bank,
which is
battery
just like sitting under the service module and just like powering all the system. Not very much. So if you're obviously going for some stuff like melting metals or something like that, you have to bring your own power for this. But for normal operations, somewhat you can get some power from there. So that's good.
Wow.
And you're putting everything together, and then you're going for the environmental testing. So shaking this, simulating a launch, and that's the moment where everyone is just like standing around and The older ones are kind of like cool already because they've done it so many times, but when you're doing this for the first time, you're really kind of like having a little bit just like, oh God, I hope this does not break. And it's not for the faint of heart. So we actually kept the hatches open, and I could see it still bluely blinking there, and just like, okay, it's got still. It's just like, it's an interesting fact. So yeah. And as soon as you've done all of this, you got a flight validation certificate. So you are basically saying, okay, this is now allowed to go to space. And this is the fun part where we then come from a long part of building, planning, designing, testing, everything. That's kind of like a lot of time which can go into there. And then you're going to the S range in this case in Sweden, in Kiruna. And this is this Skylark Tower or launch tower there, but we also got multiple other kind of launch facilities there, but that's kind of like the old and prestigious one. So depending on the type of rocket you're going into there or not. These days there will be kind of like a really interesting field trip. You will reassemble all the systems of the rocket again there. You will have a lot of launch tests. You will throw your timeline. Normal timeline in this kind of operation takes 6 hours, so 6 hours countdown. And there's happening stuff left and right of there because of so many different payloads included into something like this. And this is basically, then where you're just like sitting there for some days, testing, rehearsing, dry rehearsal, like NASA or anything else is also doing stuff like this, seeing if everything worked out. And then at some point, it's just like it's go time. And you're standing there getting into either the bunker or out of there to the field to really watch it with your own eyes, which is breathtaking. Then you can stand on top on there and just like see the rocket go. And the cool thing which I love about the Moraba guys and also MP, that they are having 2 GoPros outside of the camera, so you can, and I know we have to link into there as well, we can see it afterwards, you can watch the rocket fly and be into space, which is kind of like, I was just like standing there, I couldn't do anything. It was just like one of the best moments of my life. I really have to admit, it was really cool. And yeah, so we reached, in this specific flight, we reached about a little bit less than 250 kilometers of height. We had about the planned 6 minutes of microgravity, and then the whole thing comes down, has a heat shield, re-enters, parachute. And the cool thing is, if you're doing life sciences and biology, you get like kind of like this, oh, your payload is really important and it's going to spoil. So you are getting the helicopter treatment. So my dear colleague Jens Hausleger was allowed to go out there and then grab the samples from the still warm rocket and getting them back early. So that's how they found it in the field. GPS tracking and everything obviously is still a possible thing. And then we could get cracking in the morning hours, remove everything, secure the data and the specimens and back everything up. And then some hours later, this thing came also back by a helicopter, and all the rest of the teams could then work on this whole thing. And yeah, this is basically how this campaign wraps up. But then at this point, the work starts. So you're writing, obviously,
that's when the work starts?
Yeah, that's when the work starts.
It seemed like a lot of work already.
The rest is kind of like a little bit of fun. So it's work in some case, but it's still interesting. But then you started going through everything, and you're analyzing your data. You're seeing the first thing as we see here, the whole graph of the data acquisition from the engineering part of one of the ESPs. And I'm seeing it's basically the whole flight is shown by the lift off, by the start of the microgravity phase and the end of it, and it was working completely fine. So that's obviously the most important thing about this. Then the cool thing for our colleagues from ME, they got some nice parameters in their microscope, so they can now start analyzing how these specimens will behave under microgravity conditions. So that's for them the important science part, but they also get the data from my environmental sensor, so they can see under which circumstances, hyper-G, micro-G, temperatures, everything, how they behave. You're writing papers. If you get the chance, which is always a great thing, because then you can basically put all what you learned into some form and give it out to the world so that other engineers can learn from your success and especially from your failures. So what did not work out, which is something I think sometimes gets forgotten, and that for the worst part, because I think it's also important because it's science we're doing here and not something which everyone's doing. So shouldn't be ashamed to say, okay, this did not work out. So
yeah, I mean, a lesson learned is super valuable. Absolutely.
then we got some nice PRs, like from Belena. They had some nice reports for this, so this was kind of like really cool. We also got an honorable mention from Hackaday, which was also really, really, really nice. And yeah, so this wraps up the first campaign. And the cool thing was, it went that well that we were, okay, come on, we try to do second one. And
but before the second one, do you want to answer some questions from the first one?
Sure. Yeah, a couple of questions rolled in. Let me scroll back up. Yeah, interesting. Yeah.
So you can say that you. Oops. Oh, yeah. All yours, David.
No, I didn't. I don't think I was clicking. But this one, I think, is kind of a comment, actually, for Allison. So you could say you build innovative space hardware on your desk. I think he absolutely can say that.
I try to.
Yeah. David was asking, do they use Belena Cloud to monitor devices? I think, if I remember correctly, that this was standalone. This was not using Belena Cloud for any, orchestration. This was just taking balenaOS, which is open source, as a minimal Linux-based operating system that can run containers. Frau then asked about normal GoPros, or are they modified in any way?
They are actually GoPro Heroes, and they are modified only slightly. So actually, these are the real ones. But they also have a really, really, really nice shell. So obviously, and yeah, but yeah, so these are really great. But they basically are the normal stuff, just like taken into a special shell so that they do not burn up directly, because yeah, it's getting hot in there.
Yeah, and then of course this very important one for my shot, JR. Do you play the final countdown by ear? I think
sadly no.
I think you need to incorporate that.
Yeah, exactly. Probably our traditions, right?
Yeah. So I'm looking at the clock real quickly. We are at 11 minutes or so to go. So just keep that in mind as you go, Nico. But that's just amazing stuff you just showed. Sure. So what's Mark II, Mark III?
Yeah, Mark II, Mark III are basically the next iteration. So we got a new camera, which is a little bit more interesting in certain aspects, which I come to, and we got a small student experiment sensor board. So this thing basically has everything it needs to talk to the rocket directly. So everything kind of like voltage or sensor data or anything, it can just like directly speak to the rocket, and you can program it with Arduino. And then add your own SPI, I2C, UART sensors to the interface, and then you can basically make it completely easy to develop small experiments on a small scale for students or other quick experiments where you're just like, oh, I'm standing here in the field, I got still some grams left, so let's throw it in. So but the good thing about this, or the new payloads, is we got a new microscope, or the Flight Medicine got a new microscope which they want to cover us, and so we built this new camera. But we also, or I also want to have not only flight hardware like the experiment, but also want to try to push the science or the tech behind it always. So this time we also got telemetry and telecommand and an onboard multiplexer. So we can basically have multiple payloads which can route over this one payload and talk the normal CCSDS space standard for telemetry and telecommand and communicate with ground. So we can basically control it while it's flying. And what's even more cooler, during the microgravity phase, we will see the live video from the microscope on ground while it's still in air. And this gives us a lot of more interesting things. We also designed a new service module simulator, so which basically gives us the possibility to test the whole system without just like trying to get a rocket for testing first, which is also really good. And we designed a lot of glue. So EGSEs, or electrical ground support equipment, which basically gives us the possibility to, in lifetime, receive and command a thing from any place in the world. So basically, this system is now taking the data, telecommands, telemetry, video, countdown, and event clock from Sweden, and gives this to us in Cologne. And from this point on, we could, even if we had multiple experiments, get this data to other positions, scientists, or use it ourselves, work with this in the control room. So we could have 10 payloads in there with 10 different scientists and get us to the laptops of people working at home and controlling their own experiments while this thing is flying. Wow. And obviously ground segment with mission control software displays and everything which we normally use. And for the first time, which is really cool, we got the allowance of the chief scientist to live stream the camera and everything during this upcoming flight, which is really nice. And we even got this already a little bit tested, so we are looking really forward to this. And yeah, we're going obviously telling you about
how's
this.
the communication running?
Yeah, how do you live stream something like that? I mean, you need some high bandwidth coming off of the rocket.
Yeah, it basically this thing still got analog video channels, so this is not really a problem. Data is a little bit limited, but for telemetry and telecommand it's completely more than okay. And yeah, and we got these analog video channels, and the big antennas of Morava are picking this stuff up, getting this locally into a specific net where this stuff is delivered. And then we just like pick into this and transfer it with some kind of methods which we will write in a paper.
Gotcha.
Because it's open source.
That means that you need now electricity and another cable for data, or how does it work?
It's the same DSUP. So you got telemetry, telecommand, power, and rocket signals like I'm leaving the pad, you got microgravity, your microgravity ends. It's all in one socket, a 15-port. And only the video channel is a specific BNC cable, and that's basically it. And that's kind of like an empty chamber we see there. And this is a little bit dark, but there we can see some completely unknown software, which we also use to interestingly work with the stuff to get data visualized. It's called Grafana.
Yeah, we're familiar with Grafana.
Yeah, and so this one is going to be really big bang. And now for the last slide I got, after this, which hopefully will take place in fall, we are trying to secure funding for the next mission. After that, we want to make 2 new iterations. We want to go a little bit away from the Raspberry Pi Zero and now go to some more powerful things like, I don't know, maybe a compute module. Try to have a new design which will allow us to have higher throughput sensors, so faster scan rates on there. A new improved multiplexers actually sitting behind me. We want to do a little bit, try to test tensor accelerators, so if they can working, and we have an industrial corporations for better security of this stuff running, which will be really interesting. And the last things, which is really coming to this end, is our service module simulator needs some overhaul and a little bit more punch. So I want to include their automated testing for the flight hardware, simulating the whole flight over and over again, so you can basically have this automatically done. And also for the whole glue components or EGSEs, which basically make the data transfer possible from the ScienceNet to us in Cologne. And I see a lot of potential there because a lot of the stuff is already Dockerized, but we need to move to another platform. So I'm quite sure there will be some Belena Fin 2.0 or something like this coming around somewhere, and some Belena engine, and oh my god, yeah. So we're looking really forward to this because that will fit this industrial need to build just a little box which has a lot of compute modules in there and stuff like that, and we can just like ship it as a small little container and put it there and just like say go. And yeah, that's basically what we're trying to achieve, and this was the last slide I got. So if you have any questions left.
We had one just roll in from Girish. He was asking, is any of this data made available to the outside world, like for other scientists?
At the moment, it's still not, because these are normally you got the European standards. I don't know how it is actually made. Normally, you got like 10 years where you're working on this stuff, or you have to publish it after 10 years. But I think on some experiments, you can make the data available for even faster than that. So there's obviously some experiments which are done there, which are probably in some kind of contract where this is not available or not possible. But I guess some of this data could be made available at some point. And I would be actually really happy about this, because I'm always into for this open science or open data movement. I think that's kind of like everyone benefits from that, but it's not yet theirs.
All right.
How different are missions from the International Space Station missions?
So basically, you can get data from the International Space Station because they are trying to build now, or they're just building a science data center, And basically, after 10 years, this data is going to be there and will be published for everyone to use, so that you can basically see what happened on the Rosetta mission or something like this. So for the citizen science aspect, something like that. And it's more than just like fair, because if Europeans or other citizens are paying for this with their tax money, they should be made available for this data. At least it's my point of view. So I have to admit, everything I'm saying is my point of view, obviously, and not the one of my company. But I guess that's fair.
Yep. So we did have a couple other questions roll in as well. David H. was asking, is there a future role for Belena Cloud, being that you're going to be using the fin? I'll start off with an answer to that question, and then Nico, you can sort of wrap your context around it. But for the most part, I mean, you're really only using one device. There's really not fleet management unless you're launching lots of rockets simultaneously. So I definitely get why you're just using balenaOS, but is there something where you see Belena Cloud as a possible solution? Maybe if it's like testing of multiple units on the bench, perhaps?
Yes, especially if you're going for this whole EGSE solution. So basically the ground support equipment which you need, otherwise the testing equipment, otherwise the stuff which will get the telemetry, telecommands, videos and signals back. These are sometimes multiple systems or separated systems for load balancing reasons and everything. So at this point, it would completely make sense in the case to make a fleet management in some kind of like open Belena or something like this, because of the privacy reasons and contractual requirements. But that's something which basically could be really good for this kind of thing. So you can run or program your software, check it in there, and then let it update from your own servers, VPN systems or something like that. So definitely a good idea. On the rocket itself, that's more of a problem because, as I said, you normally have to completely disable all radios and everything. Right. So normally you're going for an offline approach, or at some points you even have to go, even if your experiment's getting too big, especially on a Raspberry Pi Zero, which is running out of space so fast, then you have to go for the completely Yocto way. But going Yocto is also kind of like going Belena, because Belena is kind of like supporting Yocto really much with this, so we are in good hands there, I guess.
Yep. Makes total sense. I don't see any other questions. I see a lot of nice comments. We've got AB, very nice, Nico, amazing. We've got I Shot JR. This is so cool. Thank you for sharing today. And Akil was saying that this experiment method has high potential to replace the experiments that we perform on ISS, and probably at a fraction of the cost too. Neat.
And I think I read that Ingenuity, the helicopter in Mars, is the first robot outside of our planet that is running on Linux. Do you have any? Do you know if there is more experiments or something?
A lot of the systems done by JPL were actually running Wind River Linux or Wind River systems. So that's always kind of like a derivative, but then also a real-time operating system with a little bit more. I guess in the future we will see a lot of more things going into the open source solutions, because a lot of companies or startups are now taking over. We got the old ones, like obviously big ones, which I'm not going to name here, which are still doing their kind of work with their basically hardware which they designed somewhere, and the aspects how they learned it. But space has to move a lot quicker now, because the scientists want their data. They do not want kind of like data like 10 days after, especially if they can get it. They want to do in situ experiments, just like sitting on the ground while the rocket's flying and seeing how it behaves. And sometimes, like in our case, luckily, they even want to share it with the world at the same time, just to say, hey, that's the first time we're trying to fly this specimen, and it will be in our thing. And I'm so generous, I just like want to share it with the world that everyone can see. That's the best part about like being open about this. And I think we will have a lot more future activities with that, especially going to the moon. And that's something we're also really interested in, because that's where everyone is moving in. And ISS is great and nice, but ISS is going to be at some point out of commission, and everyone is moving to the moon. We got missions like LunarNet and the Lunar Communications and Navigation System services, which are now going to be planned around the moon. So basically GNS, Galileo, GPS, data communication services all around the moon communicating with Earth. And we will going to have IP connectivity at some point. So going with normal Linux systems, taking down us, even on ISS. We're running a lot of new payloads now, which are running Linux or something like else, and are directly connecting not via CCSDS telemetry standards, but via IP. We got this MPCC, KU via IPS, so IP communications over KU band from the ISS, and you going down there in our systems, you're making up your PuTTY and you're starting to talk to your payload. And I think this is kind of like the future because it breaks down the cost so much and it leaves room for innovation, new startups, moving faster and getting more ideas in there and getting more for the money, because money is, we're not in the 80s anymore. We cannot do stuff like they did in the old times. It would be really cool. I would have loved to have done that stuff, but it's not how it works anymore. And on the other hand, it's really cool because now is the time where you can shine and innovate and do something new approaches and work with this, and not because the old ones obviously will need time to adapt. So I think it's a good place to be at the moment.
Cool. David, we have seen some guests here doing balena push to the Antarctica. Do you think that in the next 55 episodes we're going to see someone doing balena push to the moon? Or what do you think?
I don't know. 55 episodes, that's approximately a year. Ooh, I don't know.
That's going to be rough. I don't think the communications means will be there until there. So we are planning, I think NASA and ESA is planning to have this system like really operational in 2030. So we're going to need to stretch those episodes a little bit if we want to do it.
I think the day is going to come where we do a balena push to the moon. But I'm not sure about within 55 episodes.
Yeah, we need to talk with the GPL guys.
Yeah. Well, I don't know. I mean,
Linux by balenaOS and do balena push to Mars.
I don't know. Maybe Nico can make it happen. We'll see.
We hope for the best. We'll try.
Yeah. All right.
What else? Achilles mentioning that AstroPi, IceCube,
Yes. So the Raspberry Pi, AstroPis are basically running on there. And funnily, I talked with those guys running the AstroPis, but they're still running this on the normal Linux. And I was just saying, hey, there's this new approach called Docker and Belena. Maybe it's something like this. But it's hard to get this stuff into there if there's kind of like, there are these workflows which are pinned down in operations procedures. And IceCube is kind of like a commercial platform, so you get little cubes and put them onto this experiment unit. It's basically the same like a rocket. It gives them power and everything and can work from there. It gives the data down to the customer, and there sits at home and just like performs on his little cube there his experiments. And these are the ways where we can really make something new happen and get the cost down.
Because I was joking about like the next 55 episodes, but actually one of these missions, how long it takes since it's, someone tells you, hey, there will be a next mission until...
Yes. So actually, under normal circumstances, I think normally if you're speaking about Morpheus, I think Morpheus is going to launch twice a year, normally. But the problem is, due to the current human Morpheus situation, as we're calling it, that has been a rough time. So basically, the Mark II, Mark III were slated for launch and start of 2020. And I think I got now the third scrubbed launch, hoping for the fourth opportunity in fall. And this is kind of like, you're sitting here and just like waiting for seeing if your construct is working so you can start with the next iteration. This is really kind of like nerve-wracking, just like seeing you preparing everything, kind of like give it like your baby, like a little pat on the head, like you were doing fine, giving it away, just like heartbroken, and then it comes back like they say I still wasn't allowed to fly, and just like it's horrible. It's just like bad parenting somewhat. So it's kind of like I think, but the guys are really doing an awesome job. I mean, or just like sit back because of too many people on site. And now they launched 11 with a really, really bare minimum of personnel, just like got everything pressed. And under these special circumstances, they still were able to launch a campaign now, finally, for the first time since this whole thing broke. And I think this is kind of like a really major achievement. They did a good job with that. And we are really looking forward and hoping that everyone gets the vaccination, keeping in line with all the rules here. Everything is hopefully staying safe. And we hope that in fall, we maybe finally have to launch and can share a nice live video with you, with me frantically mumbling around in the control room and trying to get stuff working.
I'm looking forward to it. We can...
yeah, absolutely.
Sure,
yeah,
sure.
We'll be sure to promote that.
So...
All right. Something else, David? You want
no,
to ask,
I think that's it. I don't see any other questions. I mean, obviously, Nico, that was incredible. Thank you for taking the time. Thank you for all of the knowledge. I see all these comments about how awesome this stuff is that have rolled in. I guess, Mark, let's do one last quick glance to remind folks of the positions. You had it ready to go. That's perfect.
Yeah, of course.
So by all means, let me drop the link in as well. You can take a look at our open postings. Covered them at the top of the show. Technical sales lead is our customer success team. SREs responsible for the platform and fleet health, and then design your own role. Security and front end still posted. No, you're all right.
Scroll, sorry.
Yeah, it's okay. I got it. I knew him. I knew him by heart. It's all right. Live stream, Girish. Live streams from space would be great. You are correct, Girish. Link is in. There you go. And I think
that was a great episode.
Good.
Super inspireful, and probably if a lot of teenagers watch it, probably they would like to be like you in the future. So that's
we always need some new people, so it's always nice. And
let's not forget. If you need some help, you let me know.
Sure thing. Gonna call you.
You give me a phone call. We'll make this happen. We'll put this on the moon.
Remember, if it doesn't run Belena, you have to throw it during the next.
Well, I gotta check it out. Well, take a look at what's inside of that thing. I'll find out next week. All right. Well, I think we're good.
Thank you very much for having me, and for the opportunity to speak up. So. So thank you very much for this.
Well, we appreciate you taking the time, Nico.
No problem.
Exactly.
Most welcome.
All right. Bye, everyone.
Bye,
Have
everyone.
a good weekend.
Bye, guys.